All right, everybody, stop your grinning and drop your linen. We got the Daily Space Weather Show coming at you once again from the Smash News Network, least busted name in news. I'm your host, Dan, a.k.a. Smash. Mash. These are the past 24 hours from Solar Dynamics Observatory. That's two different wavelengths there, 1600 plus 171 angstroms. Here's 1700 plus 171 angstroms. And don't worry, we've got lots more solar imagery for you. We never skimp on that on the channel. Before we get to any more of that, let's take a look at the HMI instrument briefly to see a fairly low number of sunspots here at the moment. Sunspot number is currently about 73. There is the colorized magnetogram for today, January 30th, 2024. Let's briefly talk about volcanoes, and here's a sight you don't want to see in person. A pyroclastic flow at Merapi. Pyroclastic flow, not an optimal way to go. So please heed volcanic exclusion zone warnings, lest you be looking up the business end of one of those. That is not the way to spend your afternoon. Here are the other quakes that are erupting. Quakes that are erupting. Yeah, quakes that are erupting. That's what I said. I meant volcanoes that are erupting. So yeah, Merapi's on the list, producing extremely dangerous pyroclastic flows. Semeru, Popocatépetl, Santiaguido, Fuego, Nevado de Ruiz, Sangre, Revenador, Sabancaya, all producing volcanic ash or erupting in some capacity or another. Next, we'll get to earthquakes for the past 90 days. There are the past 90 days. Here are the past 24 hours. We'll cite quakes of a 5 and greater magnitude. It's been pretty quiet here on a global basis. So some pretty funky quakes there, sort of in the middle of the North American continent as well. And practically no 5 and greater magnitude quakes all day, until this 5.1 struck the South Sandwich Islands at 13:10 Universal Time this afternoon. It was at depth, over 100 kilometers estimated depth. And that, besides this 5.0 in Indonesia, was the only 5 or greater magnitude quake. That Indonesian quake occurred at 18:05 Universal Time. And let's get back to space, since it is where it's at. And we'll get to the radio flux and so forth here in a moment. First, the imagery. Yeah, you don't want to skimp on the imagery, right? So here it is. There's another 24-hour video for you from a Solar Dynamics Observatory. 171 angstroms is the house favorite wavelength. If you've got a wavelength you like better, let us know in the comments. What's your favorite wavelength? We've also got ionized helium, 304 angstroms. Another classic wavelength. Anyway, let's get back to some space weather stats here. The 10.7 centimeter radio flux is now at 135 solar flux units. 135 is the new radio flux number. There's the 1-year graph to contextualize it. Radio flux there represented by the black line. Sunspot number is the red line. And continuing right along to our space weather enthusiast dashboard, they're forecasting some geomagnetic unrest tonight. So that's basically at any moment here. Looks like it's just a result of the coronal hole high-speed stream, which has been ongoing, by the way. We do have an ongoing coronal hole high-speed stream, which we'll get to here in a minute as well. So first Earth's magnetic moment from space for the past 4 hours. There you go, our Geospace Magnetosphere movie. It depicts magnetohydrodynamic pressure. And yeah, we do have an elevated solar wind velocity, solar plasma temperature. We'll get to it. It's a coronal hole high-speed wind. So that's Earth's magnetic moment from space, modeled by the Space Weather Modeling Framework. Here's Earth's magnetic moment from the ground. It is fairly geomagnetically calm. But again, we do have some high-speed solar wind showing up. So that's a thing. So that's what Earth's magnetic moment from the ground likely looking like for the past 4 hours. Geospace delta B changes to Earth's B field. Next, our KP index is at 2.33. KP 2.33 is the KP index. There you go. And next is some solar wind data. So here we go. Solar wind is next. There's the data from ACE. Let's skip it and move to the Discover, as it just recently resumed following a minor blackout. So here we go. Discover currently showing about 7 protons per cubic centimeter for the solar wind density. Solar wind velocity here again still elevated at 460 kilometers per second, having reached peaks of about 530, it looks like. And you also see this ongoing lengthy signal here of plasma temperature on the bottom. The green row down there, that's plasma temperature. Coronal hole high-speed stream continues. Next goes magnetometers there, pretty chill. No real surprises there. Next, our top view ecliptic plane field plot. Earth yesterday snapped into a North Pole-oriented magnetic heliosphere sector. Kind of right toward the middle of that. Looks like a new sector boundary crossing's coming once again in about 2 or 3 days. Probably like 2 days. I suspect sometime after tomorrow's daily space weather video. Here's our line of sight field plot, depicting lots of different important solar features all at once. The solar B field in blue, polar fields in red and green for south and north respectively, and the photosphere magnetism shown here in grayscale. It's the past 4 days of Earth's line of sight magnetic field plot. Which brings us to coronal holes. There is our coronal hole line of sight plot, and we've got a mix of north and south pole oriented coronal holes on the Earth side of the solar disk. Let's take a look at those from SDO. There we go. There is our 211 angstroms wavelength. And before we get to sunspots, let's take a look at some stats. Sunspot number, like I said earlier, is at about 73. 73 sunspots is the current number, according to Rob, the Royal Observatory of Belgium. So here's our synoptic map, and we have a decreased likelihood of large solar flares since yesterday, mainly because of the setting of some sunspots in the western limb. There still is some fleeting possibility of large flares from some other groups, but like I said, pretty unlikely here at the moment for large flares. So here's our flare probability monitor and scoreboard. And the sunspot in the northeast is going to be the most likely place to see large flares at the moment. Now, we may see an increased likelihood also at the limb, especially in the southeast. So that's another place to watch for solar flares, but likelihood of large solar flares now has decreased quite a bit. Anyway, here's the SVO continuum, once again from the HMI instrument, showing the photosphere. And this sunspot up here is the one most likely to produce large flares. That one right there. That is the most magnetically complex sunspot at the moment. The most magnetic polaric shear is from that sunspot group. So continuing on here, let's move back to solar energetic particles and flares. We've seen the proton flux here dipping back toward baseline levels as well. The polar radio blackouts have just started to subside. So throughout the day today, HF radio restored at both the poles. The X-ray flux here fairly minor. We've only had C-class intensifications in the past 24 hours, the largest flare being a C5.7. And let's take a look at the most active sunspots. It would be the T-mass, which would be the upper right, your northwestern limb. So there you go, the upper right corner there, the most active sunspot of the past 24 hours, producing that C5.7 class solar flare. So pretty pretty quiet 24 hours here in terms of solar activity. Continuing on to our star chart. There you go. That's what's going on overhead Lehigh Valley, Pennsylvania. And thanks for tuning in to the Smash News Network, least busted name in news. So this is what's going on overhead now over Lehigh Valley, Pennsylvania. Saturn is setting up there. Jupiter is much higher on the ecliptic. The two gas giants there appearing in the early dusk skies. Next, our solar system forecast. We'll show you where things are today. Ta-da! And here's where things will be in 1 week. On February 6th, as another month is almost shot to hell. Completed. Next, our astronomy photo of the day, which is the Japanese Moon Sniper, the Lunar Sniper mission, which didn't really work out very well because, as you can see, the boosters are pointing up and this thing's supposed to be on its side and its solar panels aren't facing the right direction, and that's suboptimal, especially as lunar nighttime is about to come for the lander. So suboptimal, as it won't be charging its batteries due to the upside-down landing configuration. So Lunar Sniper is the astronomy fail, or you could say the astronomy photo of the day. Moving right along to coronal mass ejections. That's what's next, right? CMEs. And here we go. What do we got? We have a few. That's 80 frames from today. And we do have some relativistic particles striking the SOHO as well. You can see right at the beginning, right in there, you can see a bunch of little interference-looking things. Those are likely relativistic particles generated by one of those CMEs. There you see it really good on the LASCO C3 over there on the right. We'll let that play all the way through for your viewing pleasure. Number 1. If coronal mass ejections encourage you to take a number 2 in your pants, please calm down. It's not that scary. Engage. So yeah, some CMEs there. Do we think that they're earthly directed? Well, not so much. So we're going to show some more imagery here. I didn't know where to put it. So there's 171 plus 211 angstroms. And here come our CME images. So some 24-hour videos for you here where we synced up the LASCO C2 and C3 and the SDO 304 angstroms wavelength. You see that little flash of little dashes there? Those are likely relativistic particles. And yeah, you might be wondering if those CMEs are earthly directed. And the answer is, we don't think so. So once again, quite a bit of activity happening there in terms of coronal mass ejections, just not earthly directed ones. We don't see any filamentary motions on the Earth side of the solar disk. Let's move in one step further, drop the C3 and add the 193 angstroms. There you go. And yeah, those are from behind the limb as far as I can tell. I don't see any earthly oriented CMEs and none that look like they have any earthly directed components. Let's go back for just one more little stop here. There may be a tiny earthly directed component in this little CME from down here, but it didn't create much of a halo. It's not very exciting. So right down here, there is one event that did happen. I see a little bit of limb darkening there. It could have an earthly directed component. If so, it'll arrive sometime on the 2nd of February. If it does produce an impact, it won't be a major one. Very unlikely to produce a geomagnetic storm. So those are 24-hour videos, which brings us to filaments. So let's zoom in one more step here, and then we'll go to Cerro Tololo, Chile, to take stock of filaments. That's a great view, by the way, also 193 plus 304 angstroms. Great at showing lots of depth and contrast in the solar corona. Next, and there we go. There's Cerro Tololo, Chile. And quite a few filaments on the Earth-facing portion of the solar disk. And again, you can see a prominence there rising in the southeast. There is likely a sunspot somewhere behind that southeastern limb. Here is the colored view. Cerro Tololo, Chile, folks. the ground-based Hydrogen Alpha Telescope, part of the National Solar Observatory. And before we get to bonus features, the last couple of hours from GOES 16 SUVI. Little minor CME happening down there in the southeast as well, heralding the arrival of a possibly new sunspot. And let's get the bonus features, starting with satellite charging hazards. So we do have some minor surface charging there over the Middle East, parts of Eastern Africa, etc. There you go. There are only minor surface charging hazards, not likely to produce a lot of communications breakdowns. Next is the GOES electron flux. Finally coming up off the floor. I think I forecasted this one. What does NOAA have to say? We'll get to it after we show the 1 year. There's the 1 year chart of the greater than or equal to 2 mega electron volt electron fluence or electron flux. And yeah, I think NOAA's going to be off there. So there's the forecast for a little uptick I told you about. So yeah, it's what you see after a coronal hole high-speed stream. So perhaps we're seeing that subside here. You can expect an update coming soon there where we'll see a little bit of a higher observation marked by a yellow diamond versus that green box, which is the forecast by NOAA. Next, we'll show the layer where those are measured. The F layer of the ionosphere is, in many people's opinion, the bridge between Earth and space. So here we go. The F layer, shown right there, is at 300 kilometers of altitude approximately. And here is the vibrational frequency. Come on, come on. Feel it, feel it. Feel the vibrator. That's a song by Marky Mark and the Funky Bunch from back in the late 80s or maybe the early 90s. If you remember that song, make sure you let us know in the comments. And don't tell Marky Mark that I called him Marky Mark. I hear he doesn't like that name very much. And I don't like that crappy rap music that he made very much either. Anyway, here's the anomalygram as well, depicting anomaly in megahertz from the 30-day median. And we will see a little bit more red than usual here, but it looks like it's subsiding pretty rapidly. So a little bit more low-frequency anomaly than is normal, and that's because of that ongoing coronal hole high-speed stream. Don't expect that to continue into tomorrow's daily space weather video. It should be subsided by the time we put out tomorrow's content. Next, our WAM, or whole atmosphere model, depicting total electron content on the left, maximum usable frequency on the right. It's good for both GPS operators and HF radio users. The Global Ionosphere Nowcast. And we will close out space weather and move to meteorology right after we show the latest images. So there's the latest HMI intensitygram. There's the latest HMI magnetogram. There's the full disk rockback. Again, most likely place for a large solar flare is up in that northeastern limb up here, right up here. This is where, not northwest. Northeast is what I meant, right there. Second most likely place for a large solar flare is down here in the southwest. Northeast followed by southwest. And it's time to move to meteorology. But before we do that, don't forget to participate in our Ask a Particle Physicist segment. So, the deadline, and the eons are closing. The deadline is, well, really it's Thursday morning. So, I mean, I guess I could say Wednesday night is the deadline. But ultimately, the whole point of having a website is so people can do things whenever they want to. So if you want to ask a particle physicist a segment, first of all, make sure you subscribe to Eugene's channel. But secondly, go to smashomash.com/forum, go to the General Science Forum, and you too can submit a question for an actual particle physicist. So thanks to everybody who's contributed. And I've got an idea as to what this week's question will be if nobody else comes up with a better one. Let's get to meteorology next. So we're starting out with the latest sea level pressure and surface winds. So there's the Pacific Ocean, and this is what's bringing a bunch of moisture once again to the Pacific Northwest. That is a pretty strong low pressure there out in the Pacific there. 963 hectopascals is the pressure of that. And let's take a brief look and find the world's lowest pressure, shall we? So that's 963 up here. We've got 957, so that's a stronger and bigger low. And down here we've got an even bigger one, 944. So there you go. There's the world's strongest low and probably the world's stormiest seas in the Southern Ocean, as they often are, right off the coast there of Antarctica. Here come our regularly scheduled meteorology sections, starting with surface winds of the east, the jet streams of the east, the jet streams of Europe, Africa, and the Middle East, the central world. Here are the surface winds. Shout out to our viewers from all around the planet. Make sure you leave a comment if you never have before, especially if you're new to the channel. Press subscribe, as otherwise you may not see the world's most comprehensive daily space weather content and detailed solar imagery. Surface winds of the western world looking like that. And there are our jet streams. A huge divergence happening there in the jet stream just off the left coast of U.S. There, huge divergence, driving cold air way down to into the equatorial Pacific and driving some warm air way up into northwestern Canada. Next, clouds and fog for the Americas. There you go. And let's take a brief look at all that moisture that's coming in from the Pacific. The Bonsai Pipeline, the Pineapple Express, the Atmospheric River, whatever you want to call it. It is swirling around that powerful low that we showed you earlier. And there you can see some of that moisture just showing up at the left coast as we produce the video. Next, this is our windy.com map of clean air turbulence. So this is an interesting one. We've never shown this one on the channel before. So, windy.com has a free mobile app and has many great features. This one is clear air turbulence for all of our pilots out there. So let's take a look at this area near Lubbock, Texas. That's the turbulence at 5,000 feet. And as you move up, it goes away. So you got to be at about, 6,400 feet to get over that turbulence. And you can just move this slider back and forth all the way up to flight level 450 or 45,000 feet. So there is some turbulence up there, believe it or not, but it's a lot more rare than it is down at the surface level. For example, South America's got some certainly turbulent landings going on. Turbulent descents and ascents, undoubtedly. Anyway, windy.com is where to get that from. Weather.gov is where to get this from. It's the National Weather Service's homepage. So if your location is lit, click your location at weather.gov. Those are too many counties for us to cover. I wouldn't even cover that many counties if I wanted to, much less had the time, energy, and inclination to cover that much weather. But that's what's going on for weather warnings. Here comes some forecasts, starting out with the 72-hour temperature anomaly forecast in degrees Celsius. So the entire country here, as far as the lower 48, for the most part, staying well above normal for this time of year. It's the coldest time of the year, so we'll take some warmer temperatures than normal here in Pennsylvania. Although I'm a fan of the extremes, so I like snow and extreme cold temperatures just as much as I like to go riding the bicycle on 100-degree days. Next, our accumulated positive snow depth change forecast in inches and some heavy snow coming to California once again. Some areas there pushing 2 feet in the east central portion of the state. Shout out to Smash Staff's mom. Also, some more Pennsylvania snow coming here in scattered portions of the eastern Pennsylvania, parts of Ohio, and anyway, there's the map. I'm not going to try to explain it. There it is. Here's our pressure and precipitation forecast as well. Once again, the GFS 72-hour model. And quite a bit of Pacific moisture here is going to be making its way across the U.S. once again. So those forecasts are from tropicaltidbits.com. Check it out, tropicaltidbits.com, if you've never seen it before. Shout out to Levi Cohen. Perhaps go follow him on Twitter or something. And if not, I definitely don't care. Make sure you follow us on Twitter at x.com/smashomash. Anyway, Next is lightning. That's where the strikes have been for the past about 10 hours. And here are the past, that's the past 1 hour, I believe. Yeah, I think that's 1 hour. But lightning strikes are pretty sparse right now. Only 8.3 strikes per minute, so very low levels of lightning here at the moment on a planetary scale. We'll close out the video with U.S. Doppler radar for the lower 48. First, the full 50-state view. And we'll fixate on the lower 48 view. There is the clouds and fog satellite view. 3.9 micrometer shortwave infrared radiation. And there is the water vapor map. A bunch of dry air here in the process of moving all of that moisture out to the east. Two separate dry air masses there, one a bit colder than the other one coming from Canada, the other one kind of making its way across the country from the west. Here's your recap. U.S. Doppler radar, ground-based systems that show vertical motion in the air column. Space-based systems that show infrared radiation from clouds and fog. Finally, space-based systems that show the dry air, the moist air, and everything in between. And last but not least, here's me signing off from the Smash News Network, least busted name in news. I've been your host, Dan, a.k.a. Smash-O-Mash. And may that solar wind be at your back. I'm going back to the bunker. Whoa!